Hello everyone, I'm Professor Diwa, and welcome to a math video on quadratic functions and their graph. Our objectives are to graph quadratic functions of the form f of x equals ax squared, graph quadratic functions of the form f of x equals a times the parentheses x minus h squared plus k. Alright, so let's get started. First, we're going to go over a quadratic function. It states here, a quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers, and a is not equal to 0. In the next set of examples, we're going to go over graphing quadratic functions in different forms. For example number 1, we need to graph the following functions. Now the following functions are quadratic functions of the form y equals ax squared. This type of graph is also known as a parabola. What we're going to do is graph the functions as well as explore how changing the value of a from positive to negative will affect the shape of our graph. So let's start with part A. Here we have f of x equals x squared. We're going to graph this using the point plotting method. So below I have an x and y chart. The x values are already filled in. We have -2, -1, 0, 1, and 2. So all we need to do is substitute each value of x back into the function f to get our y values or our f of x values. We're just going to do this mentally. So taking -2 and plugging it in for x, we get -2 squared is going to be positive 4. -1 squared will be 1. 0 squared will be 0. 1 squared is 1. And then 2 squared is going to give us 4. Next, we go ahead and plot our points. We have -2, 4 here. We have -1, 1 right here. We have 0, 0 here. We have 1, 1 right here. And our last point, 2, 4 is right here. Next, we go ahead and draw a curve through our points. So this is the graph of f of x equals x squared. This parabola opens up or faces upward. This takes place every time our value for a is positive. Moving on to part B, we have g of x equals -x squared. Again, we're going to use the point plotting method, so we have our x and y chart below. For the x values, we're going to use the same values from part A, so we have -2, -1, 0, 1, and 2. To get our y values or our g of x values, we just take our x values and substitute it into the function g. Again, we're going to do this mentally. So -2 squared is positive 4, but the negative sign in front will change it to -4. Taking -1 and squaring it, we get positive 1, and then the negative in front will change us back to -1. 0 squared is 0, and the negative won't change the value of 0, so we get 0. 1 squared is 1, and then we have a negative in front, which will change this to -1. 2 squared is 4, and then the negative will change this to -4. Next, we go ahead and plot our points. We have -2, -4 right here. -1, -1 is here. 0, 0 is here. 1, -1 is here. And our last point, 2, -4 is here. Next, we draw a curve through the points. So this graph here in red represents the graph of g of x equals -x squared. You could see here that this parabola is the same shape as f of x, except that it's facing downward. This is facing downward because the value for a is -1. Whenever we have a negative value for a, or a is less than 0, our parabola will open downward. Next, we have a few extra details we need to go over. So a parabola also consists of a vertex, which is at the very middle of the parabola. The vertex for both of these parabolas is at the point 0, 0. It can be the highest point or the lowest point on the parabola. For the red graph, g of x, the vertex is the highest point and the center of the graph. For the blue graph, f of x, the vertex is the very center of the graph and also the lowest point. We also have what's called the axis of symmetry. This is the vertical line with the equation x equals 0. This crosses the vertex at 0, 0 and splits the graph directly in half. If we took part of the parabola that is on one side of the axis of symmetry and reflected it across the other side, This would give us the complete graph of the parabola. Next, we have a practice problem. Graph the following. For part A, we have f of x equals 1/2 x squared. For part B, we have g of x equals 2x squared. For this practice problem, make sure you go over the solutions, as I do go over a few details about the value of a and how it affects these graphs. Alright, so go ahead and pause the video, graph each problem, and then check back with the video to see the solutions. Alright, so let's go over part A. For part A, we're using the point plotting method, and we need to fill in the y values for our chart. So for -4, we get 8. For -2, we get 2. For 0, we have 0. For 2, we have 2. And for 4, we have 8. Plotting these points on the graph, we have -4, 8 right here. -2, 2 is here. 0, 0 is here. 2, 2 is here. And 4, 8 is right here. Next, we draw a curve through the points, and now we have our graph. So there's a few things that I want to point out about this graph. So the first part you guys should already know. Our a value here is 1/2, which is positive. So this results in a parabola that faces upward. The second thing I want to point out here is that the shape of our parabola is wide in comparison to the graph of x squared. This happens whenever the absolute value of a is a value between 0 and 1. Next, let's move on to part B. For part B, we need to fill in the y values for our x and y chart. For -4, we have 32. For -2, we have 8. For 0, we have 0. For 2, we have 8. For 4, we have 32. For this graph, I'm only going to plot the points -2, 8, which is here, 0, 0 is here, and 2, 8 is over here. Next, we draw a curve through our points. So this is the graph of g of x equals 2x squared. Notice here that this graph is narrow compared to the graph of x squared. The graph of a parabola will always be narrow whenever the absolute value of a is greater than 1. In our case, our a value is 2. So essentially what's happening is the distance between our y values is stretching by a factor of 2. In part A, the value of a was equal to 1/2. So the distance between the y values are cut in half, and this resulted in a wide graph. Also, we have our vertex for both of these graphs at 0, 0, and our axis of symmetry is at x equals 0. For example number 2, graph the following and find the vertex, the axis of symmetry, and label the graph. For example number 2, we're going to graph a function in the form y equals a times the parentheses x minus h squared plus k. This is also the graph of a parabola. For this example, we're going to explore how the values of h and k affect the position of our graph. For part A, we have g of x equals parentheses x minus 3 squared minus 5. First, we identify the value for a, which is the coefficient in front of the parentheses. So the value of a is 1. This means our parabola will open upward because the value of a is positive. Next, we identify the value for h. H is going to be the opposite value of the number inside the parentheses next to the x. We have -3 inside the parentheses, so h will be positive 3. Next, we identify the value for k, which is the number on the outside in front of the parentheses. So k is equal to -5. Later on, we'll talk a little more about h and k. First, let's go ahead and plot this using the point plotting method. Below, I have an xy chart, and I need to pick some values for x. The first x value we're going to choose is going to be the value for the vertex. To figure out what that value is, we need to find the x value that makes the inside of the parentheses of the function 0. You can see we have x minus 3 inside the parentheses. The value of positive 3 will result in 0. So we're going to start with the x value of 3. Next, we need to find the corresponding y value. We take 3 and substitute it into the function g. We get 3 minus 3 is 0, 0 squared is 0, 0 minus 5 is -5. So the vertex is located at the point 3, -5. Next, we need to pick two values above 3 and below 3. So I have 5 and 4 and 2 and 1. Next, we need to find the corresponding y values. So if we take 5 and plug it into the function, we get 5 minus 3, which is 2, 2 squared, which is 4, 4 minus 5 is negative 1. If we take 4 and plug it into the function, 4 minus 3 is 1, 1 squared is 1, 1 minus 5 is negative 4. If we take 2 and plug it into the function, 2 minus 3 is negative 1, negative 1 squared is positive 1, 1 minus 5 is negative 4. And then finally, taking 1 and plugging it into the function, we get 1 minus 3 is negative 2, negative 2 squared is 4, 4 minus 5 is negative 1. Notice here that we have symmetry across the y values. Above negative 5, we have negative 4, negative 1, and below negative 5, we have negative 4, negative 1. The reason why this happens is because parabolas are symmetric across the axis of symmetry. Remember, the axis of symmetry is a vertical line that divides the graph in half and runs right through the vertex. This means that the vertex is in the center of the parabola, so we will always have symmetry around the vertex. So now let's go ahead and plot our points. We have 5, negative 1 here, 4, negative 4 here, 3, negative 5 here, 2, negative 4 here, and 1, negative 1 here. Next, we go ahead and draw the curve through our points, and now we have the graph of G. Next, I labeled the vertex at 3, negative 5. We also graphed the axis of symmetry, which is the vertical line that intersects the vertex and has the equation x equals 3. So notice here that our graph has the same shape as the graph of x squared. The only difference is our graph is shifted 3 spaces to the right and then down 5 spaces. Notice that 3 and negative 5 are the same values for h and k. H will shift the graph left or right, and k shifts the graph up or down. A few last things that I want to point out is that the h and k values are the same values as the x and y coordinates of the vertex. In general, this is always true, so the vertex is always located at parentheses h, k. Also, because the axis of symmetry is a vertical line that intersects the vertex, the axis of symmetry will always have the equation x equals h. Okay, so now let's move on to part B. We have f of x equals negative 2 times the parentheses x plus 3 squared plus 5. First, we find the value for a, which is negative 2. This means that our parabola is facing downward because the value of a is negative. Also, because the absolute value of a is a number greater than 1, this will result in a parabola that is narrow. Next, we identify the value for h, which is negative 3, and the k value is positive 5. This means that our vertex is located at the point parentheses negative 3, 5, and the axis of symmetry is x equals negative 3. For our x and y chart below, we're going to use the x value of negative 3 in the middle, and then pick 2 values above negative 3 and below negative 3. So I picked negative 4 and negative 5, and I also picked negative 2 and negative 1. Next, we need to find the corresponding y values. Starting with negative 5, we take negative 5 and substitute it into the function. So negative 5 plus 3 is negative 2, negative 2 squared is 4, 4 times negative 2 is negative 8, negative 8 plus 5 is negative 3. Next we have negative 4, negative 4 plus 3 is negative 1, negative 1 squared is 1, 1 times negative 2 is negative 2, negative 2 plus 5 is positive 3. Next we have negative 2, negative 2 plus 3 is 1, 1 squared is 1, 1 times negative 2 is negative 2, negative 2 plus 5 is 3. Finally, we have negative 1, negative 1 plus 3 is 2, 2 squared is 4, 4 times negative 2 is negative 8, negative 8 plus 5 is negative 3. Next, we go ahead and plot our points. So we have negative 5, negative 3 here, negative 4, 3 is here, negative 3, 5 is here, negative 2, 3 is here, and then finally negative 1, negative 3 is here. Next, we graph our curve through our points, and now we have our downward facing parabola, which is narrow. We also have our axis of symmetry, which is a vertical line at x equals negative 3, and our vertex at negative 3, 5. Next, let's talk about how the h and k values shifted our graph. So this graph here is exactly the same as the graph of negative 2x squared. The only difference is our graph is shifted 3 spaces to the left because of the h value of negative 3, and our graph is shifted 5 spaces up because of the k value of positive 5. Next, we have a practice problem. Graph the following and find the vertex, the axis of symmetry, and label the graph. Here we have the function f of x equals negative 1 over 3 times the parentheses x minus 4 squared minus 3. Alright, so go ahead and pause the video, take your time graphing the function, and then check back with the video to see the solutions. Alright, so let's go over the solutions. The value for a is negative 1/3, the value for h is positive 4, and the value for k is negative 3. Since our a value is negative, this means our parabola is facing downward, and because the absolute value of a is a number between 0 and 1, this results in a wide parabola. Since our h value is positive 4, this means our graph is going to be shifted 4 spaces to the right, and because our k value is negative 3, our graph is going to be shifted 3 spaces down. So our vertex is going to be at 4, negative 3, and the axis of symmetry is at x equals 4. Next, we go ahead and fill in the chart. For the x values, I chose negative 2, 1, 4, 7, and 10. For the corresponding y values, I got negative 15, negative 6, negative 3, negative 6, and negative 15. Next, we go ahead and plot our points. However, I skipped plotting the points negative 2, negative 15, and 10, negative 15 because it was way off the graph. So I have 1, negative 6 plotted here, 4, negative 3 here, and 7, negative 6 over here. Next, we draw the curve through our points, and now we have the graph of our function. Next, we label the vertex at 4, negative 3, and we draw the axis of symmetry at x equals 4. Next, we have a short summary of details for graphing a parabola in the form f of x equals a times the parentheses x minus h squared plus k. Here it states the graph of f of x equals a times the parentheses x minus h squared plus k has the same shape as the graph of y equals a times the parentheses x minus h squared. If k is positive, the graph of y equals a times the parentheses x minus h squared is shifted k units up. If k is negative, the graph of y equals a times the parentheses x minus h squared is shifted the absolute value of k units down. The vertex is at the point parentheses h, k, and the axis of symmetry is x equals h. For a greater than 0, the graph opens upward and has a minimum function value k. For a less than 0, the graph opens downward and has a maximum function value k. Also note that h represents a horizontal shift. If h is positive, then the graph is shifted h units to the right. If h is negative, then the graph is shifted absolute value of h units to the left. Next, we have a practice problem. For the quadratic equation, f of x equals 1 over 2 times the parentheses x plus 4 squared plus 1, answer the following. For part A, does the graph open up or down? For part B, is the graph wide or narrow? For part C, is the graph shifted left or right? For part D, is the graph shifted up or down? For part E, find the vertex and the axis of symmetry. Alright, so go ahead and pause the video, try out these problems, and then check back with the video to see the solutions. Okay, so let's go over the solutions. For part A, does the graph open up or down? Since the value of A is equal to 1/2, this is positive, this indicates that the parabola is going to open upward. For part B, is the graph wide or narrow? Since our value of a is 1/2 and it's a value that's between 0 and 1, this indicates that our parabola is going to be wide. For part C, is the graph shifted left or right? Since our value for h is equal to -4, this indicates that our parabola is going to be shifted left 4 spaces or 4 units. For part D, is the graph shifted up or down? Since the value for k is equal to 1, this indicates that the parabola is going to be shifted up 1 space or 1 unit. For part E, find the vertex and the axis of symmetry. The vertex is at parentheses -4, 1, and the axis of symmetry is x equals -4. Alright, this pretty much wraps up our video. Thank you very much for watching. I'm Professor Diwa, and I'll see you in the next one.